Hi, I'm Rajendra. I'm a SQL developer. Uh, Today we're going to discuss about uh, techniques to improve query performance. Here is my website http://www.questquery.com if you to browse. I keep posting important question and answers, and you can give your feedback, and as well as you can post your own questions and format and to encourage this website. So every developer must uh, know that after, for example, after you have designed your database, your client uh, wanted felt that performance of the database is very slow. He wanted to improve the performance of the database. He can feel that there are a lot more spaces where you can improve performance. So for example, he will given you the database or SP or SQL server, and he asks you to look into that. So unless you have knowledge on full work items of the SQL server, unless you have full knowledge on everything in SQL server, you cannot go ahead and improve the performance. If you want to if you are very interested in learning uh, of improve performance of a query, you must be know everything about SQL server functionalities, features, everything. So for example, I will tell you on my experience in my previous company. Is a one travels company website is there. So when the lot of users hits into the database in some in one web page, uh, performance is very slow. They they verified the stored procedures, they verified the web application, they verified everything, but they couldn't find anywhere the what the actual problem was. So I had a good name in the office as well as company and in the project, so they asked me to look into that. So I again went into the in-depth analysis of the uh, problem actual problem actual problem, and observed that I used SQL profiler and performonter, some other tools, and identified in one scenario where it's impacting on performance. So what I have done, so exactly I found that when you do insert, update, delete operations on one table, obviously it's giving performance cost. So I found the table name, and again I verified that any triggers are associated with the table. So I found it. Finally, I found it that there were few figures has been defined in that table. So when the one row added to the table, so aggregation kind of functions uh, executing in a trigger, and in trigger itself calling other store procedures, so it's impacting the performance of the table. So we had clear discussion on that, and we have come up with other solution. And once we have removed the triggers, and we have implemented a job where it executes every 5 and 6 minutes, and it do the proper execution, proper aggregate functions. The purpose of this aggregate functions is to generate the reports. Actually, when you generate the reports, obviously if you do the aggregations of all the on the table, it's better. So instead of that, you want to see performance oriented reports, you can create a job where you can do aggregation calculations for each 5 minutes. So either way you can do that. So we remove the triggers. Now application is very performance oriented. So here, if you want to know, if you want to figure out where the actually problem, you have to know about the triggers. You have to know that a trigger is associated to the table. So you must know knowledge on triggers, tables, how trigger files when insert, operate, deletes being up, be, being uh, file ignition table. So this is the main aspect you should mind when you do performance or performance when you do performance. So other things. Apart from this, other things, indexes is a very plays very important role in improving the performance. So every developer must know when you should create a index against a table, on a table, when you remove indexes on a table, when you delete indexes on a table, or manage index on table, create everything, management everything, indexes on a table. How you should know when we should when you should do all these tasks is important. So depends on these management, indexes management performance heavily impact on the application. So the next one is implementing partitioning solutions. Implement partitioning solutions is nothing but it's very useful for huge applications. For example, a table contains huge data, GBs data, or huge data. You can go for a partitioning, because partitioning nothing but one disk C drive cannot handle huge data. So as well as when you do searching or filtering operations, obviously it's the performance. In that case, by date criteria or something criteria, you can split the data into different partitions and store in different disks, and depends on the searching criteria, you can pull out the data within minimum time. Also it's improve the performance if you do the right way, this partitioning. So next one is control execution plans. So capture execution plans, these two are very important. So if you see the query analyzer, you can see execution plans or execution plans in XML format or any other format, so you can understand easily how actual execution plans has been defined when you write the query for store procedure. So next one is very important, very important tool is SQL Server Profiler. Every developer should know about this. So using SQL Server Profiler, what events being raised for a database or a table, or you can get the information about of that. And for example, if you enable a SQL Profiler tool for a store procedure, you can identify the when it hit, when it gets fired, and how much time it has taken to finish it off its execution. All those information easily you can get. So next one is database engine tuning advisor. It's very important tool. If you are not much of knowledge on creation indexes and index maintenance, you can go for this. Even if you want to collect the output from the database, or if you want to collect the information about how can you improve performance using uh, database engine tuning advisor, you can go for it. So once you use this tool, you will get the information about index maintenance, like do you need to remove any indexes, create indexes, all the stuff you will get there. And collect the information from system metadata. Most of them don't use this. So mainly we are going to cover about tuning queries. How should we, which rules you should follow to tuning queries and index maintenance, because these two are very important topics where you can identify you can boost the performance if you follow these two, if you have good knowledge on these two. Tuning queries means, it doesn't mean that how to write queries, how to create indexes, delete indexes. You must know, understand everything, all aspects of SQL Server, as I said already. This is not tuning queries you must know. So it's it's very important to know everything, how SQL Server works, uh, from top to bottom. You should know. If you know that, only you can do better tuning queries, better query, improve the better query performance. Evaluating query performance. So one of the main aspects of the query performance is measuring performance. When measuring performance, you need to know how to exactly measure. What is exactly measure, on what basis? So there are three main metrics to consider query performance or consider. One is query cost, and then page rates, and third one query execution time. What is query cost? It's not been added. Sorry. Query cost. Query cost nothing but it is a good metric to compare query performance. So query first gives the information, but it depends on the CPU IO input output operations and CPU response time. It means CPU resources. All these factors are come into picture when you use query metric. So next one is one important you should remember that the lower the query cost is better query performance theoretically. So UDFs and CLRs are not considered part of the query cost. If you use user defined functions, obviously that is not part of the query per cost. Page reads. Page reads nothing but the page read represents the number of 8 kilobytes database accessed by the SQL Server storage engine while executing a query. You can retrieve this metric by executing or writing set statics IO on top of the query. So the output message should be something like that. So for example, I have run the fact table and I have written the set statistics I want top of that query, and finally I got this. So how do you find that? How many page reads are there? How many page reads this SQL server access? How many page reads? So how do you count the total page reads for this query? So here page reads nothing but sum of logical reads. Here logical reads 24 and logical reads 9. So sum of these two logical reads you can find the total page reads count. Here it is 33. So logical page reads. The next one is logical reads. Logical reads are the number of pages read from memory, not from disk. The page reads method does not take into account amount of CPU IO operations, and page reads are typically not a appropriate performance measurement as the query cost. Query cost is a better performance measurement than logical reads or page reads. Page reads because it's fully dependent on the CPU resources and all those stuff. And the last one is query execution time. Query execution time. So how do you know how much time is consumed to execute a query or a store procedure? It is a widely used metric to measure query performance, but it depends on IO operations and resource contention on the server as well other metrics. So if you write set statistics time on top of query SQL, or returns the execution time in milliseconds. And thank you.